Okay, this is just a lesson real fast to cover some miscellaneous things that we missed. I just got to view the test that we are expected to take at the end of this unit, and there are a couple things that I did not get to cover. Most of the things that we've seen is okay. As it says, we've learned about the fundamental parts of these three sections, 4.1 through 4.3, but there are still some other processes that will be expected of us in 2 weeks on that assessment. And this video is just going to talk you through some of the information. It's up to you to ensure that you actively participate and ask me about anything personally that might be still confusing to you. So pretty much once I cover this, it's expected that you know it and that you try to apply it, or that you can apply it whenever that test pops up. In terms of one thing that we're talking about is rates of change, which we've seen. All of our graphs so far have been given with the x variable counting by 1. This will not always be the case. We'll be expected to find the rate of change for other types of tables that are not made this way. So what I mean by that is, and this isn't the example you need to write if you're writing anything, is that we've seen things where our graphs always go from 0 to 3, or from 1 to 3 to 4 to 5, and everything is consecutive. But what we're going to see is questions like this, to where they're going to ask us if it's linear, and to still write an equation like we've been doing, but you notice that these numbers do not go directly in order, and so we have to kind of adjust what we know to apply it to this new situation. And it's really not that bad. The good news is we already have the foundation that we need to get it done. And so what you want to do here is you still want to determine what the difference is between the two numbers. So we know we will still do 4.1 minus 3.5, which is 0.6. And it's going up by 0.6, and because this is going up by 1, that is fine. That is an increase of 0.6. The problem here is that when you take 5.3 minus 4.1, that is not 0.6. That is actually plus 1.2. But what we are going to do with this number, because this is increasing by 2, is we're going to divide that by 2, which of course is 0.6 again. So again, what you do, you still do the same thing we've been doing here, which is finding the number between the y values, or the dependent variable. But if it is a difference of more than 1, you simply divide that difference by whatever is there. So looking at this one here, we have 5.3 to 7.1, so we take 7.1 minus 5.3, which is 1.8. But since this is adding by 3, we divide that by 3, of course, and that is 0.6, if I am right. Yep. Which means that because we get 0.6 on all three of those differences, yes, it is linear. And if they want a rule, remember, as long as that matches, that means that we are doing 0.6x. We just have to adjust it. And again, the way we adjust it, this is a number that a lot of you did not understand before. 0.6 is my difference. But what we have to do now is take 2 and plug it in and try to make it match 3.5. And 0.6 times 2 is 1.2. And in order to get from 1.2 to 3.5, we have to add, I believe, 2.3. And so that would be my rule, except you'd put a y equals in front of it. So again, that is what we learned, combined with just a different type of table where the numbers are not nicely lined up as 0, 1, 2, 3 or 1, 2, 3, 4. So again, it's not a big shift. It's just making sure you understand that whenever the jump is bigger than 1, that you simply divide whatever your difference is by whatever the x's did. So looking at one more of these, here again you're looking at 7.3 to 10.3, which is a difference of 3. But if you look over here, this is a difference of 2, so we divide that by 2, getting a difference of 1.5, and it's adding 1.5. Looking here, we have 10.3 to 14.8, which is 4.5 here, but in between these two we have a difference of 3, so we divide 4.5 by 3, which again gives us 1.5. And if you're looking at this one, this is a straight 1.5, and because this is a difference of 1, we know that it's 1.5. So again, yes, this is linear. And what we do now is, because our difference is 1.5, we put 1.5x. The nice thing about the graphs with 0 is that whenever you put 1.5 times 0, you get the answer of 0, and so this typically represents what you will add on to it. So it's 1.5x plus 7.3, and that would be our rule. Again, if you tested that out, 1.5 times 2 plus, I'm sorry, give me a parentheses, plus 7.3 gives me my 10.3. You can do the same thing with the other one. I'll do one more just to verify. 1.5 times 5 plus 7.3 gives me the 14.8, so it still works. So again, the only difference between the graphs that you saw and what you might see on a couple of problems on the actual test in a couple of weeks is that the x's will not be consecutive. But considering what we just did, I don't think it's that bad of an issue. You just got to make a slight adjustment. The second thing is that they're going to ask you to represent it in words, an equation, and a graph. It says so far many of our questions have been on the computer, but unfortunately the test is on paper, so you're going to be given a table and asked to represent the table in words with an equation and with a graph. We've hopefully learned how to do the equation part, I think, especially with the three things, or I think it's 4 different equations or types of equations that we had to learn for today's quiz. I just need to be sure you understand that you are also skilled enough to do the other two things. So let's consider the following questions here. We have one where it says determine whether the relationship is a linear function, then represent the relationship using words, an equation, and a graph. Again, if they want to know if it's linear, I don't care if they give me a graph or not. All I'm going to do is look and see if the difference is the same. And so everything pretty much starts the same. We look here and we see from 2.4 to 3.8 is 1.4 over here. Unfortunately, this is a difference of 2, so we have to divide it by 2, getting a common difference of adding 0.7. In order for this to be linear, everything else has to make 0.7. Looking here, this is, I believe, 0.7. 4.5 minus 3.8 is 0.7. And that difference is 1, so we just use it because a difference of 1 is what we want anyway. And then checking the last one, 5.9 minus 4.5 is a difference of 1.4, but again the difference in our independent variable is 2, so we divide that, getting again a difference of 0.7. So notice that everything we've done so far is everything we've been trained to do, which is find the common difference. If it's immediate, then we know that we put 0.7 attached to x, and then we use what we know to adjust it. So 0.7 times 1, of course, is 0.7. And we need 0.7 to get to 2.4, so we need the difference or the distance, and so I'm just going to do 2.4 minus 0.7, which tells me that I must have to add 1.7 to it. And again, you can always check with your calculator real fast, doing 0.7 times the next number, which is 3, plus 1.7 to make sure excuse me, that it matches. And it should also do the same thing for 4 and 6. But once we get there, what we have to do now is represent it with words. But notice that the first thing we did was we did the equation. The equation is typically going to be the first thing you do. And so what we have to do now is excuse me, represent it with words. And so what you say here is the gallons is found by multiplying this column, which we see as days, by whatever we multiply it by, which is 0.7, and adding 1.7. So overall, all we're doing is taking what we have already in our equation and simply saying it in words. But we have to do it in terms of what our topics are. So this being our dependent variable represents y. This being our independent variable represents x. So we have to say that whatever this is found by multiplying this number, which is days, by what we found, and then adding on whatever our adjustment number was. And that'll get us there. The last thing we have to do is the graph, which they don't give us any graph paper or any line paper, so you have to kind of wing it a little bit and kind of get your best picture there. Typically for me, I just count what my days are going up to. Remember, that's here, and I need to get up to 6, so I go 1, 2, 3, 4, 5, 6, and then I do my best count up to about 6 here. So 1, 2, 3, 4, 5, 6, and then from there you make your best guess. 2.4 means go over 1, that's your days, and then up 2.4, so up 1, 2, and a little bit less than a half, which is somewhere around here. 3.8 means go over 3, and then up 1, 2, 3.8, which is pretty close to 4. 4.5 means go over 4 and up 4.5. 1, 2, 3, 4, and about a half, somewhere around there. And then 6, 5.9 would be 1, 2, 3, 4, 5, pretty close to 6. And you notice that they are in a straight line because it should be, since it is linear, and that we can draw a line through those dots. But for the most part, as long as you're able to get those dots about where they should be, I have to give you credit, because if they're not giving you a table and they're not giving you perfect numbers, then it's very much a approximation type of thing. Let's look at one more here before we get ready to quit. It says determine whether a relationship is linear, then represent again using words, an equation, and a graph. In this one here, we have to pay attention to the fact that this is going down 9 while this is going up 3. And so when we divide 9 by 3, it means that our rate of change here is -3. Here we see that this is going from 10 to 4, which is down 6, while this is going up 2, and so we divide it by 2, again getting a change of -3. Here from 4 to 1 is a -3. Since that is a 1, that means that again is my rate of change. And so again, yes, it is linear because I have the same thing. Again, because that is my rate of change, we will put -3x. Now remember, what we do is we plug in one of the numbers. It doesn't matter which one. I'll just put the 2 in there, so -3 times 2 is 6. I'm sorry, -6. And how do I get from -6 to 19? Well, you take where you want to be from what you have, which is -6, and I put 19, not -6, but minus -6, because that's where I am. And that gives me 25. Now here's the thing, if I did do 19 minus 6, think about the fact that it doesn't make sense that 13 steps would get you from below 0 up to 19, so that's kind of like a way to self-check that. But 19 minus -6 does give me 25, which means that I am going to add 25 to that for my equation. Then from there, again, you would say the people are found by multiplying, because we are multiplying, the number of minutes by whatever we did here, which is -3, and adding 25. That's your words. So again, once you find this, once you've done all the work, all you have to do is take this equation and arrange it so you can actually say it in words so it makes sense. And then the last thing, of course, they want you to do is graph it. We go up to 8, 1, 2, 3, 4, 5, 6, 7, 8. And how do I do 19 people? Well, you just kind of make, I could go by 2's if I want. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Again, I have to mark that we're counting by 2's here and that we're counting by 1's here. And from there, all you have to do is just make sure you make a good approximation. So 2, 19 would be over 2, up 19, which of course is right around there. 2, 4, 6, 8, 10, 12, 14, 16, 8. Yep. 5, 10 is over 5. 2, 3, 4, 5, up 10. 2, 4, 6, 8, 10, which is somewhere around there. 7, 4, 1, 2, 3, 4, 5, 6, 7, up 4, which is 2 marks. And then 8, 1 would be up halfway. And notice again, those are kind of linear, and we can draw it through there. So again, make sure that you add this to your understanding of what's going on before next week. If you want, one of the best things you can do or start doing for yourself, especially whenever you have your book at home, is just kind of glance at the next section. We will be doing 4.4 on Monday, 4.5, and I believe 4.6 next week. So again, if you get a chance, we actually might even be doing 4.7, but if you get a chance, just kind of glance at those things the day before we go, and it should kind of give you a foundation to determine what's going on when the information is given to you. Other than that, good luck and have a good weekend.